Okay, so we're going to go ahead and create our triangle in quadrant 4. So here's our triangle in quadrant 4, and remember, this really is the same thing. This negative radical 2 over 2 is the same thing as negative 1 over radical 2, and it's talking about inverse sine, or in other words, the sine function. So that's so, so that's opposite and hypotenuse. So just by looking at this picture, we know that our opposite is going to be the negative one. Makes sense because it's going in the downwards direction. Our hypotenuse is radical 2. So we already know what kind of triangle this is. This is a 45-degree triangle, and the missing leg here is going to be 1. Positive 1 because it's going towards the right direction. Okay, so because that is a 45 degree triangle, we're ready. Now what we can do is we can go ahead and do the tangent. All right, so tangent is TOA, TOA, TOA. Opposite over adjacent. Opposite is negative 1. Here's my angle, basically theta. So opposite is negative 1 over adjacent, which is positive 1, and negative 1 over a positive 1 is equal to a negative 1. Just a reminder for those that would like to do the extra credit opportunity on tomorrow, Wednesday, the dress up day. Remember that I said you can go ahead and dress up, but you either must take a picture with Miss Smith, Coach Andrews, Mr. Ritchie, Miss LaBeouf Thomas, or Miss Lisa Harris. One of those people, take a picture with them and send it to me on Wednesday. If I get it any other day after Wednesday, you won't get the extra credit. So again, remember, the dress up extra credit opportunity, you must dress up and take a picture and email it to me. Either a picture with Miss Smith, Miss Lisa Harris, Miss Mia LaBeouf, Mr. Ritchie, or Coach Andrews, one of those, and just let them know. I'll probably, if I get a chance, email them tonight just to let them know, to give them a heads up. For those of y'all that don't know what my email address is, I'm going to go ahead and write it up here. My email address is Cantu, CANTU, at bmtisd.com. Again, make sure that you email me that picture by 11:59 Wednesday night. Don't forget, otherwise you won't get the credit for it. That's my email address. Alright, so I've done B, D, F, H, and J. Now I'm going to be left with 3, 5, and 7. 3, 5, and 7. Alright, so here we go. New. Let's go ahead and say, actually, you know what? We're going to go ahead and say, let's work with 5. Now, if you notice, I want you to look at 3, 5, and 7. 3, 5, and 7 are very different from 2, 4, and 6. 2, 4, and 6 are giving you the interval from 0 to 2 pi, 0 to 2 pi, 0 to 2 pi. That's exactly what we did yesterday. In other words, you only go around the unit circle one time, 0 to 2 pi. 3, 5, and 7 don't have that. That means that you're not limited to only just one time. You can go a lot of times around the unit circle. So that's going to be something important that we're going to take care of in a little bit. But what I would like to do is take care of 5. Let me do 5 just to start off with. So if we go ahead and start with 5, says the tangent of x over 3 minus 1 is equal to 0. Okay, that's like me saying, this is equivalent to me saying in algebra x minus 7 is equal to 0. And what would you do in algebra? Alright, so in algebra you would plus 7, so you get x is equal to 7. Let's apply that same concept and do something to the actual problem. And what are we going to do? Alright, we're going to add plus 1 to both sides. So we therefore have the tangent of x over 3 is equal to 1. Okay, so now we have a little bit of a problem because we're not used to having x over 3 like this. We're just used to having x. So what we're going to need to do is we're going to continue. How do you get rid of this tangent? You get rid of the tangent by saying inverse tan. So we're going to go ahead and inverse both sides. So we have inverse tangent. And whatever you do to one side, you must do to the other. So we're going to go ahead and say inverse tangent. Alright, so what happens here is that your tangents cancel, leaving you with x over 3 is equal to inverse tangent of 1. Okay, so this is the tricky part. Now you have to say where on your unit circle is your tangent 1. Remember, we get tangent when you have the same x and the same y, because anything over itself is going to be 1. What kind of 1 is this? That's a positive 1. So if we remember, let's just remember or recall San Antonio Tequila Company. Where is tangent going to be positive? Tangent is going to be positive in the A and in the T. So in other words, in quadrant 1 and quadrant 3. So let's continue. So we're going to have x over 3 is equal to, let's look at our unit circle. Quadrant 1. So where in quadrant 1 are the x and the y the same? Because remember, anything over itself is equal to 1. And that happens right here at pi over 4. So that's going to be our first solution, pi over 4. But it looks like, according to San Antonio Tequila Company, we have another solution, and that's going to be x over 3 still is equal to, well, let's look at quadrant 3. Where in quadrant 3 is in our unit circle is the x and the y coordinate the same? It happens right here. It doesn't matter if it's a negative. Why? Because a negative over a negative is going to be a positive. So we're going to get the positive value, and that happens at 5 pi over 4. So we get 5 pi over 4. Now here's the part that's kind of tricky. Because we're not limited to just one revolution around the unit circle, we always add this piece after it, plus 2 pi n. And we're going to also add it here, plus 2 pi n. Why 2 pi n? Because 2 pi is one revolution, n is just how many times you go around. So it's something that's coterminal, any angle that's coterminal. But we're not done just yet, because I want to find x. Right now I have x over 3 and x over 3. So how do I get rid of a division by 3? We're going to multiply by 3 on each side. Alright, so if I multiply this times this, my 3's cancel, leaving me just with x. Now here, if I multiply this 3, remember this is, you see fractions, so let's go ahead and make this 3 a fraction of 3 over 1. We're going to distribute this in here, and we have top times top, so we get 3 pi over bottom times bottom, so 4 times 1, and we get 4. Plus, this is going to be also distributed in here, and basically that's pretty simple. 3 times 2 is, so we get plus 6 pi n. Alright, and then we're going to do the exact same thing over here. We're going to multiply both sides by 3. And by 3 over here, I'm going to squeeze it in here. This times this in here, the 3's cancel, leaving you with x. Here, if I distribute this in here, top times top is going to give me 15 pi. And then bottom times bottom is going to give me 4. Plus, then I'm going to distribute this here. I get 6 pi n. Now we need to identify n. So all the time it's going to be wherever n is equal to 0, plus or minus 1, plus or minus 2, and dot, dot, dot. Okay, you always are going to need something like that. And that, oops, that right there is going to be our entire solutions. And that's going to be number 5. Let me very quickly write them down because I'm making my key as I do this as well. All right, moving on to number 3. We're going to this time do number 3. 3 is cosine squared of x is equal to 1 minus 2 sine squared of x. Okay, one of the key things about trig equations is it really works if you only have one trig. That's how a trig equation will be solvable. You only need one trig. Here we have more than one trig. We have a cosine and we have a sine. So we need to use our previous knowledge. And what was the topic that we discussed before trig equations? Trig identities. So we're going to need to convert or change something so that the equation can be in one trig. So what I'll do is I'm going to go ahead and say this. I'm going to say cosine squared of x is equal to 1 minus 2. There's an identity for sine squared, and that is 1 minus cosine squared of x.